Namaste bachcho. In last class we started chapter 1 solid state, and there we discussed about two types of solid, that was crystalline and amorphous solid. Now today we will be discussing about classification of crystalline solid. Now the complete chapter will proceed with crystalline solid. So our topic for today is classification of crystalline solid. Based on constituent particles with which solid is made and intermolecular forces between particles, crystalline solids are classified into four types: molecular solid, metallic solid, ionic solid, and covalent or network solid. What we have to remember in these four types of solid is what are the constant particles in the solid, what are the intermolecular forces between particles, their example, and whether they are conductor or insulator. One more thing I would like to tell you, that how you will know whether the solid is conductor. If it is having free ions or free electron, then the solid will conduct electricity, otherwise it will be insulator in nature. So let's proceed with our first type of solid, molecular solid. Molecular solids are further classified into three types: non-polar molecular solid, polar molecular solid, and hydrogen bonded molecular solid. First is non-polar molecular solid. In four headings we will be discussing the complete solids. First is constituent particles. Non-polar molecules we have studied in class 11th are those molecules in which the shared pair of electron remains at the center. Two atoms to which the molecule is attached are of same electronegativity. A and B are of same electronegativity, and the shared pair of electron remains at the center. Such type of molecules are called non-polar molecules. So the constituent particles are non-polar molecules like hydrogen, chlorine, oxygen, and in non-polar molecules the intermolecular forces are London forces or dispersion forces. Since they are not having any free electron or ions, therefore they will be insulator in nature. Second type of solid is polar molecular solid. Again, constituent particles are polar molecules. Polar molecules, if A and B are not of same electronegativity, B is more electronegative than A, then what will happen? B will attract shared pair of electron towards itself, such that B will be having negative charge, partial negative charge, while A will develop partial positive charge. Within the covalently bonded molecule, charges has been developed, partial positive and partial negative charges has been developed. Such type of molecules are called polar molecules. So the examples are HCl, SO2. Intermolecular forces, dipole, two poles have been created, therefore the intermolecular forces between particles will be dipole-dipole forces. No free ions, no free electrons, therefore polar molecular solids will also be insulator in nature. Third is hydrogen bonded molecular solids. First we should know what is hydrogen bond. Bond between hydrogen and three most electronegative elements, FON, F-O-N. When hydrogen is bonded to any of these three elements, fluorine, oxygen or nitrogen, then what happens? Now we know fluorine is more electronegative than hydrogen. It will attract the shared pair of electron developing negative charge, while hydrogen will develop positive charge. Similarly, other molecule is also there with hydrogen having positive charge and fluorine having negative charge. Now, this fluorine electronegative element of one molecule will attract hydrogen of other molecule. This bond between electronegative atom and hydrogen is known as hydrogen bond. So, this bond is represented by dotted line. So, constant particles are hydrogen bonded molecules like HF, NH3 and water. Forces, hydrogen bond, which I have explained here, and it is not having free ions and electrons, therefore it is insulator in nature. Second type of crystalline solid is metallic solid, which includes all metals: sodium, potassium, copper, zinc. All metals will come under metallic solids. So constant particles are positively charged kernels and electrons. Intermolecular forces will be metallic bond, and because of presence of free electrons in metals, they are good conductor of electricity. Third type of solid is ionic solid. As we know, ionic solid is made up of cations and anions. Cations are positively charged ions and anions are negatively charged ions. So the constant particles in ionic solid will be cations, that means positive ion, and negatively charged ions. For example, NaCl. In NaCl, cation is Na positive while anion is Cl negative. Intermolecular forces between cation and anions are strong electrostatic forces of attraction. Very strong forces are these. These are the strongest forces, electrostatic forces, Coulombic forces. Insulator in solid state but conductor in molten state. Why? Because in solid state the ions are held by strong electrostatic forces of attraction. That is why it is insulator in solid state. But as we melt or heat the solid, the positive and negative ions are now free to move. Due to presence of free ions in molten state, it is very good conductor of electricity. All ionic solids will conduct electricity in molten state, but in solid state, due to strong electrostatic forces, ions are not free to move. There are no free ions. That is why it is insulator in solid state. Last type of solid is covalent or network solid. We know that covalent bond is formed by sharing of electron between two atoms. So this type of bond is generally found in non-metals. So all constant particles will be covalently bonded molecules with covalent bond as intermolecular forces of attraction. Example, silicon carbide, boron nitride, graphite, diamond, all are the example of covalent or network solid. No free ions, no free electrons, therefore all the covalent or network solids are insulator in nature except graphite. Graphite is only covalently bonded molecule which is a very good conductor of electricity. Why? Because in graphite carbon is sp2 hybridized. It is having free electrons which is responsible for conductivity in graphite. In diamond, carbon is sp3 hybridized. All the 4 electrons of carbon are bonded to form 3-dimensional network structure. There is no free electron. That is why diamond is insulator in nature. Few other examples you also have to remember, that is silicon carbide, boron nitride, all comes under covalent or network solid. So this is the classification of crystalline solids including 4 solid: molecular solid, metallic solid, ionic solid and covalent and network solid. Only these things you have to remember in this topic and the topic will finish. Thank you.